Now, how do we graph systems of linear inequalities? So system again means more than one. So now there's two inequalities. Well, really simply, you do exactly what you did with the other problems. You graph each one of them one at a time. So I'm going to call this inequality 1 and this inequality 2. Inequality 1, I'm going to go ahead and graph that. Notice that this is thankfully already in slope-intercept form, so I don't need to manipulate it. So I know that here, this is the y-intercept. The y-intercept is at 7. The slope is 3. So if the slope is 3, you could write it as 3 over 1. So that means I'm going to go up 3 to the right 1. So from the number 7, I'm going to go up 3, 1, 2, 3 to the right 1. And now I'm going to draw my line to connect the dots. And I see a greater than or equal to. So there's an equal sign on the bottom. So therefore, I'm going to make this a solid line. So I'm going to make this a solid line here. So pretend that went through. Of course, it's much more accurate on the computer when you do it on Alex. The second line here, notice that, and actually before I do that, before I get to the second line, I'm going to go ahead and shade the answer. So when I shade this answer, y is greater than 3x plus 7. Well, again, I'm going to figure out, do I shade the left side or do I shade the right side? So again, I'm going to pick my point 0, 0, and I'm going to ask myself true or false. True or false when I plug in 0, 0. So when I plug in 0, 0, I get 0 is greater than or equal to 3 times 0, which is just 0, plus 7. So is 0 greater than or equal to 7? This is false. So I know 0, 0 is not part of the solution, so the solution lies on the left side of this line. Now I'm going to graph this part now. So the second line here, I notice that it's already in slope-intercept form. -2 is the slope-intercept, so I put -2 right there. -3 is the slope, so -3, I could write it as a fraction, -3 over 1. That means I go down 3 to the right 1, because slope is rise over run, change of y over change of x. So I go down 3, 1, 2, 3 to the right 1. So I'm going to draw that graph, and notice that this does not have an equal sign, so I'm going to draw a dotted graph. So I'm going to draw a dotted line instead of a solid line. So when I draw a dotted line, it's going to look something like this. Here's my dotted line. And again, I'm going to ask myself, do I shade the left side of the red line or do I shade the right side? So I'm going to go ahead and, let me just make sure I'm doing this right. So I'm going to go ahead and test 0, 0. 0, 0 is to the right of the line. So let's see what happens when I test it to the right of the line. So the right of the line, the right side of the line, 0, 0, plug it in. 0 is less than -3 times 0 minus 2. So I plug in 0, 0 for x and y. This becomes 0. So I get 0 is less than -2. True or false? Is 0 less than -2? And the answer is false. 0 is not less than -2. 0 is actually bigger than -2. So therefore, everything where 0, 0 was to the right of the red line, so I do not shade that. So that means I shade everything to the left of the red line. So here's my red line, so I'm going to shade everything to the left of the red line. So now I see that my blue line is here and my red line is here. So the place where they overlap is the answer. So the answer then is going to be where the red and the blue line overlaps, because we're graphing the solution to the system of inequalities, not just one. So where the red and the blue overlaps is right here. Right? So in your Alex, you will be able to do that when you do that. So here is the solution where this is a solid line here and this is a dotted line here. Right? That's dotted and this is solid.